Hey class, in today's lesson we're going to talk about properties of exponential functions, which is found in section 7-2 part 1 of your book. In this lesson we're going to explore the properties of functions of the form y equals a times b to the x power. So in example 1 it says, how does the graph of each function compare to the graph of the parent function? Okay, so the first one is asking us, how can we compare 0.5 times 2 to the x to the parent, which is y equals 2 to the x. Alright, so first we need to know what y equals 2 to the x looks like, and then we will graph that same function or the next function on top of it. So if I have y equals 2 to the x, I'm going to create an xy table. And again, I'm using my same standard value, so -2, -1, 0, 1, 2. So 2 to the -2, remember, is really 1 over 2 squared, or 1/4. 2 to the -1 equals 1 over 2, which is 1/2. 2 to 0 we know is 1. 2 to the first is 2, and 2 squared is 4. Okay? And then that next one, and we should say, let's go ahead and say this is y equals 2 to the x power. I'm going to create another column to show y equals 0.5 times 2 to the x. So basically all I have to do is take all those and multiply times 1/2. So I have 1/4 times 1/2, that's going to give me 1/8. 1/2 times 1/2 is 1/4. 1 times 1/2 we know is really 1/2. But I could show that. Let me go ahead and show it. 1, which is really 1 over 1, times 1/2 is 1/2. 2 is really 2 over 1, times 1/2. It's going to be 2 over 2, which is 1. And then 4, which is 4 over 1, times 1/2 is 4 over 2, which is 2. Okay, so I will graph these in pink, and I will graph these in blue, and in the end we'll describe their transformation. Alright, so if I graph the first one, -2 and 1/4 is just a little off. -1 and 1/2 is halfway. 0 and 1. 1 and 2. And then 2 and 4. Okay, that's the first graph. So this is the parent. Okay, then the next one is -2 and 1/8, so it should be lower. I can't really show it very well. The next one, -1 and 1/4, should be still very much lower. 0 is 1/2. 1 is 1. And 2 is 2. So we can pretty much see, if you think about a parabola and the vocabulary that we used to use there, it would show you that this graph, right, the new graph, has been compressed, and the vocabulary we should use, compressed by a factor of either, you can say 0.5 or 1/2, either way. So that's how we compare it. Alright, so let's go ahead and try the next one. Again, this second one is our parent function, and that's what we're going to use as our base, and then we'll compare -1/3 times that function to the parent. So here we go. Again, we're going to use the same x values. Ooh, my x looks horrible. And we'll use the parent, y equals 3 to the x. So it's going to be -2, -1, 0, 1, and 2. Okay, so 3 to the -2 is really 1 over 3 squared, which is 1/9. 3 to the -1 is really 1 over 3. 3 to 0 we know is 1. 3 to the first we know is 3. And 3 squared is 9. Okay, and then if we use the new transform function, we're going to have y equals -1/3 times 3 to the x. So we're going to take what we just found and multiply times -1/3. So if I have 1/9 and I multiply it times -1/3, that's going to give me -1 over 27, because I'm multiplying straight across. The next one I have 1/3 times another negative 1/3. This is going to give me negative 1/9. 1, which is really 1 over 1, times negative 1/3. It's going to be negative 1/3. 3, which is 3 over 1, times negative 1/3, will give me negative 3 over 3, which is really negative 1. And the last one, 9, which is really 9 over 1, times negative 1/3, will give me negative 9 over 3, which is negative 3. Alright, so finally, if I graph Alright, the first one, again, I'll graph in pink. The second one I'll graph in, second one I'll graph in blue. Alright, so that'd be negative 2 and negative 1/9. Again, these are very, very small. Negative 1 and negative 1/3, a little further off. And these aren't negative, I apologize, I can't see. That first one was positive 1/9. So we will fix that. Alright, starting over. Negative 2 and positive 1/9 is about here. Negative 1 and 1/3 is about a little higher. 0 and 1 is here. 1 and 3, and 2 and 9. This graph goes here. That's the parent. Okay, the new transform graph is negative 2 and negative 127, so that's very, very small, barely off the line. The next one, negative 1 and negative 1/9, again, still very close to the line. 0 is negative 1/3, so still barely off. It looks closer to a half, but I can't really fix it. 1 and negative 1 is here, and then 2 and negative 3 is here. Alright, so that graph is going to look like this. Okay, the main thing that we should see, the transformation that took place, is that it reflected about the x-axis. And again, based on what we saw that a fraction did, right, we should notice that this one is a little bit more compressed. So this is also compressed by a factor of 1/3. And again, guys, this has not really changed much throughout the semester, right? Most of these things stay about the same. All right, let's go ahead and look at our try. So again, it says, how does the graph compare? So I'm going to do one and have to erase the entire screen. And then I'm going to do the second one and then move on from there. All right, so again, on this first one, this is the original. And then we're going to see what multiplying it times 2 will do. Okay, so again, that's negative 2, negative 1, 0, 1, and 2. So then 4 to the negative 2, which we really know is 1 over 4 squared, gives us 1 over 16. 4 to the negative 1 is really 1 over 4. 4 to the 0 is 1. 4 to the 1 is 4. And 4 to the second is 16. Okay, that's the first one. And then we're going to take that and multiply it times 2. So y equals 2 times what we just found. So 1 over 16 times 2, which is really 2 over 1, is going to give you 2 over 16 or 1/8. 1/4 times, again, 2 over 1 is going to give you 2/4 or 1/2. 1 times 2 we know is 2. 4 times 2 we know is 8. And 16 times 2 we know is 32. Okay, again, using pink as the original and blue as the transformed graph. And I'm not going to be able to fit all of these on here. I'll do as best I can. I'm going to use a little bit of a different graph this time. Alright, the first one is negative 2 and 1/16. Next one is negative 1 and 1/4. It's a little higher. 0 and 1, 1 and 4, then 2 and 16, which is way up here. So this one's going to look like that. The next one is negative 2 and 1/8, so a little higher. Not much higher though, I can't really get it to do that. Negative 1 and 1/2, so that's about here. 0 and 2. 1 and 8, so 1, 2, 3, 4, 5, 6, 7, 8. And then 2 and 32, which is way up here. I'm just going to go ahead and say it's here. Really bad graph, but either way, what you should notice is that this one has been stretched by a factor of 2. Again, very visually bad, but the math proves that to be correct. And if you need to, you can also throw this into a calculator. This can be your y1 and this can be your y2, and you can see it a lot better. All right, I'm going to do the second one, so I need to erase. Sorry, I know it seems like I'm just going back, but erasing is a little bit more of a hassle. All right. So here we go. Let's look at the second set. Again, this is the parent, and the second one will be the next one. So here we go. X is going to equal our standard values, negative 2, negative 1, 0, 1, and 2. Y is 5 to the x power. Okay, so that's 5 to the negative 2, which we know is really 1 over 5 squared, or 1 over 25. 5 to the negative 1 is really 1 over 5. 5 to the 0 is 1. 5 to the 1 is 5. 5 squared is 25. Okay, and then we're going to take that and multiply it times negative 1/2. Okay, so 1 over 25 times negative 1/2 is going to give you negative 1/50. 1/5 times negative 1/2 is going to give you negative 1/10. 1 over 1 times negative 1/2 is going to give you negative 1/2. 5 over 1 times negative 1/2 is going to give you negative 5/2, or negative 2 and 1/2, because we kind of need to know what that means. And the last one, 25 over 1 times negative 1 over 2 is going to be negative 25 over 2, or negative 12 and 1/2. Okay, then we're going to graph. Once again, this is going to be a very kind of sketchy graph. And actually, this one isn't going to work. Hold on. Some very bad increments. I'm not going to fit all of them, but I'm going to do my best. All right, the first one again is pink. The second one is blue. So the pink one is negative 2 and 1/25. That's hardly anything. Negative 1 and 1/5, again, hardly anything. 0 and 1. Okay, then 1 and 5, so 1, 2, 3, 4, 5. And then 2 and 25, which I'm not going to fit on here. So let's just say it's just going to go exponentially up. Okay, that's the parent. Then we know that the blue one, negative 2 and negative 1/50th, again, I can't do anything about that. Negative 1 and negative 1/10, again, I can't really do anything with that. But 0 is negative 1/2, so that's right in the middle. 1 is negative 2 1/2. And then the last one is 2 and negative 12 1/2, so that's about here. Okay, and what we should see here is once again it's been reflected about the x-axis and compressed by a factor of 0.5. All right, let's keep practicing. All right, so a horizontal shift, y equals a times b to the x minus h, is the same as a vertical stretch or compression of y equals a times b to the negative h times b to the x. A vertical shift, y equals a times b to the x plus k, also shifts the horizontal asymptote from 0 to k. Okay, so let's just kind of look at this and kind of figure out how this is going to make a difference in our graphs. So once again, we're just graphing to compare, right? So this is our parent, and we're going to compare it to what happens here. And again, we're doing this graphically, even though we can probably figure this out by coming up with a rule on our own. We're going to figure it out graphically, okay? So we have x and y equals 2 to the x. So negative 2, negative 1, 0, 1, and 2. Okay. If I substitute in 2 to negative 2, we should know that's 1 over 2 squared, which is 1/4. 2 to the negative 1, we know is 1 over 2. 2 to 0, we know is 1. 2 to 1, we know is 2. And 2 squared, we know is 4. Okay. But if I add on my comparison column, y equals 2 to the x minus 4, it makes a little bit of a difference. So this becomes 2 to the negative 2 minus 4, which is really 2 to the negative 6, which is really 1 over 2 to the 6, which is 1 over 64. All right, the next one, that'd be 2 to the negative 1 minus 4, which is really 2 to the negative 5, which we really know is 1 over 2 to the 5th, or 1 over 32. Okay. 2 to the 0 minus 4 is really 2 to the negative 4th, which we know is 1 over 2 to the 4th, which is 16. 1 over 16. I know this looks really bad, sorry. 2 to the 1 minus 4 is really 2 to the negative 3rd. So that's 1 over 2 cubed, which is 1 over 8. And the last one, 2 to the 2 minus 4 is really 2 to the negative 2, which we know is 1 over 2 squared, or 1/4. Alright, so now we need to graph. So once we graph, we're going to get something that looks similar to this. So here we go. 1, 2, 1, 2. Alright, remember the first one's going to be in pink, the next one's going to be in blue. So negative 2, oops, need some more on here, don't I? So negative 2 and 1/4 is here. Negative 1 and 1/2 is here. 0 and 1 is here. 1 and 2 is here, and 2 and 4 is here. So this is the parent function. Okay, the second one is really not going to move much at all. In fact, I'm going to show you something in just a moment, but we're going to have negative 2 and 1/64. Literally, these things are probably going to stay really, really close to the very bottom for a very long time because 1 is 1/8, which still isn't moving very much. And this is a 4th. So what I want to show you is what happens when we get 3 and 4. Okay, if I had put in 3, that would have been 2 to the 3 minus 4, which is really 2 to the negative 1, which is 1/2. Okay, so that kind of helps. So 3 would have been 1/2. So it's finally starting to make its way up. Let's just do one more, 4. If I put in 4, that would have been 2 to the 4 minus 4, which is really 2, and I'm not going to have enough space. That's going to be 2 to 0, which we know is 1. So this one, had I done 4 finally would have been 1. So what you should see is, yes, it's kind of hugging the x-axis quite a bit, but it's finally going to start going up. And that shift actually happened because it was shifted to the right 4 units. So what happened here is that it shifted right 4 units. Okay, let's look at another one. Alright, so again, this is the parent, so we're going to start there. And specifically, this one is 20 times 1/2 to the x. So -2, -1, 0, 1, and 2. If I put in 20 times 1/2 to the -2, really that is 20 times 2 over 1 squared. Now 2 squared is 4. 4 times 20 is going to be 80. Alright, 20 times 1/2 to the -1 is really 20 times 2, which is 40. 20 times 1/2 to the 0 is really 20 times 1, which is 20. 20 times 1/2 to the first is really 20 times 1/2, which is 10. And then 20 times 1/2 squared is really 20 times 1/4. So that's really 20 over 1 times 1/4. It's going to give you 5. Okay, and then we need to compare that to the next one, which is y equals 20 times 1/2 to the x plus 10. So in other words, all it does is add 10. So it's going to be 90, 50, 30, 20, and 15. Okay, so when I graph that, and I know this is going to be pretty horrible, I'm not going to show any negatives here because we don't really have much of a graph. And I'm going to count these off by tens. So by 10, or just to show you that that's 10. Okay, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so that would be for the first one, -2 and 80, which is about here. -1 and 40, 0 and 20, 1 and 10, and then 2 and 5. Okay, so this graph is doing something like that. Okay, it's definitely a decay. All right, the next one, however, in blue, the first one's going to be 90, and the second one is going to be 50, so 10, 20. So here, 0 is 30, 1 is 20, and 2 is 15. So this one hasn't necessarily done any horizontal shifting, but it has done a vertical shift. So this one has shifted up 10 units. Right, and it's very easy to see specifically here because the difference between this line and this line is 10 units. So it shifted up 10 units. Alright, so we're going to try a couple. The first one, we're going to need to, we'll do that one and then I need to erase and start the next one. So here we go. That's the parent. So again, this is -2, -1, 0, 1, 2. So this is 4 to the negative second, which is 1 over 4 squared, or 1/16. 4 to the negative 1 is 1 over 4. 4 to 0 is 1. 4 to the 1 is 4. And 4 squared is 16. Okay, this one we have y equals 4 to the x plus 2. So this will be 4 to the negative 2 plus 2, which is 4 to the 0, or 1. 4 to the negative 1 plus 2, oops, too far, which is really 4 to the first, or 4. 4 to the 0 plus 2 is really 4 squared, or 16. 4 to the 1 plus 2 is 4 cubed, or I believe that's 64, but let me verify. Yep, 64. And the last one is 4 to the 2 plus 2, which is 4 to the 4th. I believe that's 256, but I just want to make sure. 4 to the 4th. Yep, it's 256. Now, obviously, I'm not going to be able to graph those last two, but I just want to show you. Once again, let's go ahead and I'll go ahead and make these by tens. It really only goes to about 140, but it's something. Alright, so the first one is going to be -2 and negative, or a positive 1/16, so barely off the line. -1 and 1/4 again, barely off the line. 0 and 1, now that is kind of off the line. 1 and 4 is a little more off the line, and 2 and 16 is about here. So this one, oops, kind of looks like that. Okay, the second graph, however, is going to be -2 and 1, so already a little off. -1 and 4, a little higher. 0 and 16 is about here. 1 and 64, so 10, 20, 30, 40, 50, 60, about 64. And the last one, 4 and 256, we're not going to be able to see it, but this is pretty much good enough. Missed it by a lot. Because again, what we can see is that this one actually has been shifted left 2. And even if you can't see this visually right now, again, compared in a graphing calculator, this would be your y1, this would be your y2. And again, you'd be able to see that it's been shifted to the left 2. Because, and another thing that also could show you that it's definitely just a shift, a horizontal shift, is because if you can notice the pattern, this pattern here of 1, 4, and 16, sorry, I should do check marks, 1, 4, and 16 is following the same thing here, so we should know that the next ones are 64 and 256. So that's another indicator that it's only been a horizontal shift rather than a stretch. Okay, so I'm going to need to erase all this and work on the next one. almost there. Whoops. Hope that helps also. All right, so here we go. So we need to use this as the parent. Oh, I should use black. That's the parent, and we'll compare with the other one. So y, I don't know why I keep starting with y. That's really x. And then y equals 5 times, really that's a fourth, right? So a fourth to the x power. So this is -2, -1, 0, 1, and 2. So this is 5 times a fourth to the negative second, which is really 5 times 4 over 1 to the second. 4 squared is 16. And then 16 times 5 is going to give us 80. The next one, 5 times a fourth to the -1 is really 5 times 4, which is 20. 5 times a fourth to the 0 is really 5 times 1, which is 5. 5 times a fourth to the first is really 5 times 1/4, which is 5/4, or 1 1/4. And lastly, 5 times 1/4 squared is really 5 times 1 over 16, or 5/16. Alright, now if I add on that next one, I should get y equals 5 times a fourth to the x. And again, this one is just plus 5. So I'll take the same work and just add 5. So 85, 25, 10. That'll be 6 1/4. And this will be 5 5/16. Okay, so when I graph, which again is going to be a really horrible graph, but I'm going to do this by, let's do this by tens again. That's 90 up there. That's 10. Alright, so -2 and 80 is about here. And I really should be doing that in pink because I forgot to switch colors. Next one is -1 and 20. 0 and 5. 1 and 1 1/4. And then it doesn't matter because it's basically the axis. Really bad graph, but it's actually, that's really bad. Let me try that again. That's a little better. Alright, and then the blue one, which is the second one, that's going to be -2 and 85, so a little higher. -1 and 25, 0 and 10, 1 and 6 1/4, and then 2 and 5/16, or 5 and 5/16. Alright, so this one, again, should basically just show you that it's shifted up 5 units. Alright, so let's go ahead and kind of conclude on the next screen. Alright, so this last screen is just a summary of everything that we've basically done, alright? Everything for the most part was always affected by B, right? B was always considered our parent, right? Now, if A was greater than 1, happened to be a stretch, and if it was between 0 and 1, we would either call it shrink, but I tended to call it compression. And then obviously if it was negative, it was a reflection. And then we noticed that if we had some sort of x minus h here, okay, that was going to be our horizontal translation. And then k was our vertical translation. But remember, this one here is opposite. And then the last one just shows you what all of them look like combined together if we ever had one of those. Alright, so guys, that is absolutely it for this section. If you have any questions, please come see me for tutoring.